Friends, we are often confused by the vocabulary of mole concept. In this video, let us try to understand the meaning of terms like these. In chemistry, we come across atoms, molecules, ions, and formula units. And for atoms, atomic weight is defined as the ratio between mass of one atom of the element and 1/12 of the mass of one atom of C12 isotope, that is taken as the reference. And in another video, I explained why relative atomic mass is a better name for atomic weight. So understand that atomic weight and relative atomic mass are one and the same. Because relative atomic mass is a ratio between two masses, it is a dimensionless number. Similarly, for molecules, we can define molecular weight as the ratio between mass of one molecule of the substance and 1/12 of the mass of one atom of C12 isotope. That is our reference. Again, relative molecular mass is a better name for molecular weight. So, molecular weight and relative molecular mass are one and the same. Again, because molecular weight or relative molecular mass is a ratio between two masses, it is also a dimensionless number. Similarly, for ions, we can define ionic weight like this, and for formula units, we can define formula weight like this. Understand that relative ionic mass and ionic weight are one and the same. Formula weight and relative formula mass are also one and the same. And these are all dimensionless numbers. Now, what is the atomic weight of sodium? It is 23, just the number 23. Now, let us take a quantity of sodium whose mass is equal to its atomic weight in grams. That is, let us take 23 grams of sodium. And to represent this particular mass of sodium, let us create a new name. Because we have added the unit gram to the right hand side of this equation, let us add the word gram to the left hand side as well. Then we have gram atomic weight of sodium is equal to 23 grams. So, gram atomic weight of sodium is its atomic weight in grams. And in general, for any element, gram atomic weight is its atomic weight in grams. And if gram atomic weight is too long for you, you can simply drop this word and these two letters as well and call it gram atom. So, gram atom and gram atomic weight are one and the same. It is the atomic weight of the element in grams. So, gram atomic weight or gram atom represents a particular mass of the element. Now, what is 1 gram atom of nitrogen? Simple. It is its atomic weight in grams. Atomic weight of nitrogen is 14. So, if you have 14 grams of nitrogen with you, you have 1 gram atom or 1 gram atomic weight of nitrogen. Similarly, what is 1 gram atom of oxygen? 16 grams of oxygen, because 16 is the atomic weight of oxygen. Now, what is the molecular weight of oxygen? It is 32, just the number 32. Now, what do you call 32 grams of oxygen? Now you know the drill. Because we have added the unit gram to the right hand side here, to represent this particular mass of oxygen, we have to create a new name by adding the word gram to the left hand side as well. So, it is gram molecular weight. So, gram molecular weight of oxygen is equal to 32 grams of oxygen. That is its molecular weight in grams. And in general, for any molecular substance, we can define gram molecular weight as its molecular weight in grams. And if gram molecular weight is too long for you, you can drop this word altogether and replace these two letters with an E and simply call it gram molecule. So gram molecule and gram molecular weight are one and the same. And if gram molecule is also too long for you, you can drop these four letters and simply call it gram mole. So gram mole, gram molecule, gram molecular weight are one and the same. And if gram mole is also a mouthful for you, you can drop this word also and simply call it mole. So mole, gram molecule, gram molecular weight are all one and the same. It is the molecular weight of the substance in grams. So it represents a certain mass of the substance. So 1 mole of oxygen is 32 grams of oxygen. Similarly, what is 1 mole of nitrogen? Simple. Its molecular weight in grams. Molecular weight of nitrogen is 28. So 28 grams of nitrogen is 1 mole of nitrogen. What is 1 mole of methane? The molecular weight of methane is 16. So if you take 16 grams of methane, you have 1 mole of methane. So mole, gram molecule, gram molecular weight, they are all one and the same, and it represents the molecular weight in grams. Now these two are self-explanatory. Sulfate ion is SO4 minus 2 ion and its ionic weight is 96, 32 plus 64. And if you take 96 grams of sulfate ions, that means you have 1 gram ionic weight of sulfate ions. Gram ionic weight is its ionic weight in grams. And a shorter name for gram ionic weight is gram ion. So 1 gram ion of an ion is equal to its ionic weight in grams. Now, can you tell what is 1 gram ion of carbonate ions? 12 plus 48. Is it 60? So 60 grams of carbonate ions is 1 gram ion of carbonate ions. Similarly, for sodium chloride, formula weight is 58.5. So if you take 58.5 grams of sodium chloride, that means you have 1 gram formula weight of sodium chloride, and there is no shorter name for gram formula weight. So now you understand all these terms, and they are not as difficult, right? If you understand the idea behind this vocabulary. And as we discussed in the other video, atomic mass is the mass of one atom. And to get atomic mass, you have to multiply its relative atomic mass or atomic weight with 1U. So what is the atomic mass of sodium? It is its atomic weight 23 multiplied with 1U, that is 23U. And atomic mass of nitrogen is 14 multiplied with 1U, that is 14U. 14 is the atomic weight of nitrogen. Similarly, molecular mass is the mass of one molecule of the substance. To get molecular mass, you have to multiply its relative molecular mass or molecular weight with 1U. So what is the molecular mass of oxygen? Its molecular weight 32 multiplied with 1U, that is 32U. And the molecular mass of nitrogen is its molecular weight 28 multiplied with 1U, that is 28U. And the molecular mass of carbon dioxide is its molecular weight 44 multiplied with 1U, that is 44U. Similarly, ionic mass is the mass of one ion, and it is equal to its relative ionic mass multiplied with 1U. So what is the ionic mass of sulfate ions? Its ionic weight is 96. So 96 multiplied with 1U, that is 96U. And similarly, formula mass is the mass of one formula unit, and it is equal to its relative formula mass multiplied with 1U. So what is the formula mass of sodium chloride? Its formula weight or relative formula mass, that is 58.5 multiplied with 1U, that is 58.5U. And all the vocabulary that we discussed so far is not at all difficult, right? And in my opinion, life would have been much easier for all of us if this story ended here. But unfortunately, it did not. In the year 1971, out of all the names that we created here, they picked this particular name mole and gave it an entirely different meaning, and that led to an enormous amount of confusion. To understand that, we have to continue with this story. Before 1971, in the International System of Units, there were 6 fundamental physical quantities, that is in the SI system, and they are mass, thermodynamic temperature, time, length, luminous intensity, and electric current. And in the year 1971, they added the 7th fundamental physical quantity, that is called amount of substance, with the intention of benefiting the chemists. Now, what is this fundamental physical quantity, amount of substance? Now, what is the purpose of the physical quantity mass? It represents the amount of matter, right? If there is more matter, there is more mass. If there is less matter, there is less mass. Similarly, the fundamental physical quantity amount of substance represents the number of particles present in the substance. A substance that has more number of particles has more amount of substance than a substance that has less number of particles or entities. Between these two, this has more number of particles or entities than this. So the amount of substance is more here than here. So understand that amount of substance represents the number of particles or entities. And these particles could be atoms, molecules, ions, electrons or protons, and so on. And small m is the symbol for the fundamental physical quantity mass. Similarly, small n is the symbol for the fundamental physical quantity amount of substance. And every physical quantity must have a unit. The unit of mass is kilogram. Similarly, for this fundamental physical quantity amount of substance, we must have a unit. And they picked the name mole as the unit for this fundamental physical quantity amount of substance. And the symbol for this unit mole is MOL without the E in the end, just like kg is the symbol for the unit kilogram. See, kilogram is the unit of mass that represents matter. Now, to express the masses of other objects in kilograms, we need to first know the size of 1 kilogram. We need to know the amount of matter that you are calling 1 kilogram. Until 2019, the amount of matter present in a particular platinum iridium cylinder made in 1889 is taken as 1 kilogram by definition. So this is the size of 1 kilogram. Similarly, we have to define the size of mole. And by definition, 1 mole is given this number 6.0221407 times 10 to the power of 23, an enormously large number. And in honor of Amedeo Avogadro, this number is called Avogadro's number, and the symbol for this number is capital N or capital N with the subscript O. So now what is mole? Mole is the unit of the fundamental physical quantity called amount of substance, and the size of 1 mole is equal to Avogadro's number. You don't have to memorize all these digits. It is sufficient if you know the value of Avogadro's number up to 4 significant figures. Now let us say we have an Avogadro's number of sodium atoms. Then what is the amount of sodium we have, or amount of substance we have? 1 mole. Remember, the symbol for mole is MOL without the E in the end. Say we have an Avogadro's number of methane molecules. Then what is the amount of methane we have? Again, 1 mole. And if you have an Avogadro's number of carbonate ions, again the amount of substance or the amount of carbonate ions we have is again 1 mole. Now you understand a little bit about this physical quantity called amount of substance. And I think you also understand why this name mole is so confusing. Before 1971, mole represented a particular amount of mass for a given substance. 1 mole of oxygen was 32 grams of oxygen. Today, mole is the unit of the fundamental physical quantity called amount of substance, and the size of 1 mole is equal to Avogadro's number. That is why you keep hearing these two definitions of mole, and that confuses us a lot. And the confusion does not stop here. After this new fundamental physical quantity was created, we also created new vocabulary to replace all these old names. And we shall discuss that in a separate video, because we already packed a lot in this video.